Hello everyone, this is a demonstration of a very simple test of a system that I'm putting together using an Arduino Uno with a touch screen, a Raspberry Pi 4 that has connected to it via USB a vector network analyzer Nano VNA V2 Plus. The test I'm going to do is to check the communication between the Arduino Uno and the Raspberry Pi with the meaning that I'm going to send a couple of commands from the Arduino Uno to the Raspberry Pi to request it to execute a couple of commands. Those commands will really boil down to having the Raspberry Pi talk to the VNA to collect S11 and S21 data measurements that then will be aggregated, calculated on the Raspberry Pi, and the final result will be sent back to the Arduino Uno for display purposes of the final result. So this is a mock kind of a test where the Arduino Uno will go through a sequence of states where in each state will send a command and have the Raspberry Pi do some of those commands as I just mentioned. So really the purpose is to see that I can send commands from the Arduino Uno to the Raspberry Pi, have the Raspberry Pi execute a couple of other Python programs that involve talking to the VNA, collect data and send back confirmations of those commands being executed, as well as the final result back to the Arduino. There are some other things here that are part of the final project, which I'm not going to cover here. On the level shifter between 5 volt that the Arduino Uno works with and the 3.3 volt that the RX and TX GPIOs of the Raspberry Pi work with. If I wanted to show you briefly the Arduino sketch that I'm gonna run on the Arduino, I really go and start in a state called idle, where I'm going to wait for the go from the user, and then I'm going to go into sending one command, command 3. I'm going to receive that on the Raspberry Pi, which in turn will connect to the VNA and get measurements from the VNA. I'm going to wait for a confirmation that is done and move on to the next state, which will mean collecting 30 sensor responses. I'll do that on the Raspberry Pi, send back a confirmation that was done, and then move on to yet another command, which is the collection of a second reference point, waiting for a confirmation of that to happen, and then as a final state here, I'm gonna get from the Raspberry Pi the final result printed, and then be done. Move to the idle state and wait for another measurement cycle like that. So let me also show you a little bit how the source code of the very simple Python program looks like. It's really, I'm just gonna open the serial and wait for command signals 3, 4, 6, and 7. 7 will mean that I'm just gonna send back a hard-coded number to mock as a final result. So here, when I receive command signal number 3, I will be running another program that connects to the VNA and collects S11 and S21 measurements that I'll have here shown on this display connected to the Raspberry Pi shown up. So let me program the Arduino. And then open a serial monitor. And now everything is ready. On the Raspberry Pi, I'm gonna run that Python script, which right now, as you can see, is listening for a command signal from the Arduino. On the Arduino, I'm gonna start this new cycle by typing here in the serial monitor go, and as you can see, I sent from the Arduino a command 3. It was received on a Raspberry Pi, which connected to the VNA and gathered S11 and S21 measurements for a now dummy 50 ohm load. I displayed those. I need to click and close those in order to allow the program to finish. As you can see, I received here a confirmation that that was done on the Raspberry Pi. I'm sending the command for the next one, which right now means nothing. I'm not really doing anything, and on the Raspberry Pi I just send quickly back a confirmation that I finished that, and from the Arduino I'm sending a new command 6, collect reference point 2, which was received right here on the Raspberry Pi, which again executed the same program to connect to the VNA and get again S11 and S21 data that you can see displayed here. I'm gonna close those to make this go on and make progress. The Arduino received confirmation that was done. I'm sending the last command 7 from the Arduino to tell the RPI4 to send me the final result, which is just a hard-coded number at this stage to show that I can get it back on the Arduino Uno over here, and then that will be finishing one measurement cycle. If I want now to start another one, I'll just go one more time, and the whole thing repeats. As you'll see here, I received the signal 3 again, which triggers connection from the Raspberry Pi to the VNA vector network analyzer that sends me again back those S11 and S21 measurement data. So in conclusion, this is a very simple test that demonstrates how to communicate bidirectionally between a Raspberry Pi and Arduino Uno for the purpose of having the Raspberry Pi talk to and use a vector network analyzer for do other stuff.